Have you ever noticed how South America and Africa fit together like puzzle pieces? If you look closely at a world map, the coastlines seem to align almost perfectly, as if they were once joined and then gently pulled apart. This striking similarity has fascinated scientists and explorers for generations, sparking questions about the true nature of our planet's surface. That's no accident. It's a clue from Earth's deep past, a sign that our planet's surface is always changing. The rocks beneath our feet hold stories millions of years old, and the shifting plates beneath the continents are constantly on the move, shaping the world in ways we're only beginning to understand. The continents drift, oceans open and close, and mountains rise and fall in a slow, majestic dance. Over millions of years, entire landscapes are transformed. Rivers carve valleys, wind and rain wear down mountains, and the relentless movement of tectonic plates creates new land while swallowing the old. For centuries, people thought continents were fixed, but evidence in rocks, fossils, and the ocean floor proved otherwise. Fossils of the same ancient creatures have been found on continents now separated by vast oceans, and the patterns in the rocks tell a story of continents that once touched. Once, all the continents were joined in a supercontinent called Pangaea. Imagine a world where all land was connected, where animals and plants could roam freely from what is now Africa to Asia or the Americas. This ancient supercontinent eventually broke apart, setting the stage for the world we know today. Now, new forces are at work, tearing continents apart and creating new oceans. Deep beneath the surface, molten rock pushes and pulls at the plates, causing them to crack and drift. These powerful forces are invisible to us, but their effects are dramatic and far-reaching. Today, we can actually witness one of these epic events. A new ocean is being born in Africa. The East African Rift is slowly splitting the continent, a process that will eventually create a vast new sea where land once stood. A vast rift is splitting the land, offering us a front-row seat to the forces that shape our world. Standing at the edge of these massive cracks, you can almost feel the planet's energy, a reminder that Earth is alive and dynamic. The map of our planet isn't finished, it's a masterpiece still in progress. Continents will continue to drift, oceans will shift, and new landscapes will emerge, just as they have for billions of years. Geography isn't fixed. Earth is alive and always changing. Volcanoes erupt, earthquakes rumble, and the land itself breathes and shifts beneath our feet, reminding us that nothing on our planet is truly permanent. Mountains are just wrinkles, oceans are temporary, and the land beneath us is in constant motion. Even the tallest peaks and deepest trenches are fleeting features in the grand timeline of Earth. By studying Africa's changes, we connect with the deep rhythms of our planet. Scientists use advanced tools to monitor the rift, learning more about how continents move and what the future might hold for our ever-changing world. We're witnessing the cosmic forces that have shaped Earth for billions of years. As we look to the stars and study our own planet, we realize we are part of a story that began long before us and will continue long after, written in the rocks, the land, and the restless motion of our world. The East African Rift Valley is a massive scar, a dramatic wound etched into the very surface of the continent, stretching for thousands of kilometers down Africa's eastern side. This rift is one of the most striking geological features on Earth, visible even from space. But it's not just a valley, it's the birthplace of a new ocean, a place where the Earth's crust is being pulled apart, slowly but relentlessly over millions of years. Here the African continent is literally being torn in two, as if the land itself is being unzipped by powerful forces deep beneath our feet. The Nubian Plate and the Somali Plate are gradually drifting away from each other, and the land wedged between them is sinking, cracking, and reshaping the landscape in dramatic ways. This rift has shaped rivers, soil, and even the evolution of life itself. It's marked by dramatic volcanoes like Kilimanjaro in Kenya, which rise as sentinels over the shifting Earth. These volcanoes act as vents, releasing immense pressure from deep within the Earth and occasionally reminding us of the planet's restless energy. The rift isn't a single break, but a complex branching system of valleys, faults, and volcanoes, each with its own story to tell. In some places, the split is already wide and deep, forming dramatic canyons and gorges. In others, it's just beginning, a subtle crack in the arid landscape hinting at the changes to come. This complexity makes the rift a natural laboratory for scientists who come from around the world to study its unique geology and dynamic processes. By examining its different stages, from the earliest cracks to the deepest valleys, we can piece together the entire life cycle of a continental breakup, gaining insights into Earth's past and future. The East African Rift offers a rare, living example of how continents split apart and new oceans are born, a process that usually takes place over unimaginable timescales. It's a living example of geology in action, a place where the forces that shape our planet are visible and ongoing. The story unfolding here will one day redraw the map of the world, creating a new ocean and forever changing the face of Africa as we know it. To truly understand why Africa is splitting apart, we need to take a step back and look at the bigger picture, zooming out to see our planet as a whole. Earth's surface isn't a single unbroken shell. Instead, it's made up of massive tectonic plates, enormous slabs of rock that fit together like a giant, ever-shifting puzzle, floating atop the softer, hotter mantle below. These plates are in constant, slow motion, moving just a few centimeters each year. Their movement is powered by heat, rising from deep within the planet's core, creating convection currents that push and pull the plates in different directions. Where plates collide, the immense pressure forces land upward, forming towering mountain ranges. When they grind past each other, the friction triggers powerful earthquakes, and where they pull apart, the crust stretches and thins, opening up deep rift valleys. The East African Rift is a textbook example of this last process, a divergent boundary, where two plates are slowly moving away from each other, tearing the land apart. Far beneath the surface, a massive plume of superheated rock rises from the mantle, pushing upward with incredible force. This heat and pressure stretch and fracture the crust above, making it weaker and more prone to splitting. The force is so immense that it literally cracks the continent open, creating deep fissures and valleys, a dramatic sign that the process of rifting is underway. This isn't a new phenomenon. It's the very same process that, millions of years ago, tore apart the ancient supercontinent Pangaea and gave birth to the Atlantic Ocean we know today. What's happening in East Africa right now is just the beginning, the first chapter in the story of a brand new ocean slowly forming, reshaping the map of the world. These geological forces work on timescales that are almost impossible for us to imagine, spanning millions of years. Yet their effects are already visible in the dramatic landscapes and shifting ground we see today. We are witnessing the earliest stages of an ocean's birth, just as it happened countless times before in Earth's history, an awe-inspiring reminder of our planet's restless energy. The planet's engine of creation never stops. Volcanic eruptions, geothermal vents, and shifting land are all signs that Earth is alive and constantly changing. Africa's Rift Valley offers us a rare window into this powerful, ongoing process, a living laboratory where we can watch the forces that shape continents and oceans at work. For years, Africa's split was subtle, until 2005, when the ground in Ethiopia's Afar region suddenly ripped open. A massive fissure, 60 kilometers long and up to 8 meters wide, appeared in days. This dramatic event showed that rifting isn't always slow, it can happen in bursts. Scientists rushed in, using satellites and seismic sensors to study what happened. They found that magma injected deep underground forced the land apart, acting like a wedge. This event gave us unprecedented insight into how continents tear apart. It confirmed that magma, not just stretching, drives the process. Since then, scientists have tracked the region's movement down to the millimeter. The Afar region is where continental rifting is turning into oceanic spreading, right before our eyes. It's one of the few places on Earth where we can watch a new ocean floor being born. How fast is Africa's new ocean forming? The plates move about 6 to 7 millimeters a year, the speed of your fingernails growing. On a human scale, it's slow, but geologically, it's rapid. Sometimes, as in 2005, the process leaps forward in dramatic bursts. If this continues, in 5 to 10 million years, the Red Sea and Gulf of Aden will flood the rift, creating a new ocean and a large island from parts of Ethiopia, Somalia, and the Horn of Africa. The world map will be forever changed. This isn't just a guess. It's based on evidence from past events, like the formation of the Atlantic Ocean. Studying the East African Rift is like looking back in time, watching the same process that once split South America from Africa. The rift connects us to Earth's deep history. We're witnessing a replay of the forces that shaped our world. The slow splitting of land is a profound reminder of our planet's ongoing evolution. How do we know all this? Thanks to cutting-edge technology, GPS receivers on either side of the rift measure movement with millimeter precision. Satellite radar creates detailed maps, revealing where land bulges or sinks. Seismology tracks countless small earthquakes mapping the rift's active faults. Each tremor is an echo of the continent breaking apart. These tools, combined with fieldwork, give us a complete picture of the rift's evolution. We're not just guessing, we're measuring plate tectonics in real time. For the first time, we can watch a continent split and a new ocean begin to form. The birth of a new ocean will reshape Africa and the world, though most changes are far in the future. For now, the rift brings both challenges and opportunities to millions living nearby. Volcanic activity creates fertile soils and offers geothermal energy, but also brings risks. Earthquakes, eruptions, and sudden fissures. Communities must adapt to a dynamic, unpredictable landscape. Understanding the science helps build resilience and reduce risk. As the rift widens, new lakes will form, and the landscape will transform. Eventually, seawater will flood in, creating new coastlines and ecosystems. The birth of a new ocean will change climate, weather, and life in the region. It's a powerful reminder that our world is always changing. The forces shaping our planet are still at work, and their story is far from over. The East African Rift is not just a geological marvel, it's the cradle of humanity. Fossils of our earliest ancestors, like Lucy, were found here, shaped by the rift's dynamic environment. The region's unique mix of lakes, volcanoes, and savannas fostered incredible biodiversity. Rift Valley lakes are home to hundreds of unique fish species, evolving rapidly in isolated habitats. Some lakes, like Kivu, hold vast amounts of dissolved gas, a hazard, but also a potential energy source. As the rift transforms, freshwater lakes will become salty estuaries, and new marine life will emerge. Species will adapt, migrate, or vanish, illustrating the deep connection between geology and life. The rift's story is about both rocks and resilience, the adaptability of life itself. Why does this matter? Because it connects us to Earth's grand story and the universe beyond. The East African Rift is a visible link to the forces that shape planets everywhere. Watching a new ocean form reminds us that our world is alive and always changing. The map isn't finished. The story isn't over. Studying the rift helps us understand similar features on Mars, Venus, and distant moons. By learning how rifts work here, we unlock secrets of other worlds. Africa's split is a local event with universal meaning. It's a humbling reminder that the world our descendants inherit will be different from ours. We are stardust, living on a planet in motion. Understanding this process is one of science's greatest gifts.